Let's talk about NEET exam. I'm going to talk about the physics subject, and these are some of the questions it's asked in the previous years. Let's start it. So here is the question: which one of the following is not the vector quantity? It indicates they're asking which one is a scalar quantity. It's an indirect question they're asking. So four options are there. One is torque, displacement, velocity, and speed. Which one is a scalar quantity? If we discuss on torque, you are able to see the torque. It got the direction, so it is a vector quantity. And if you talk about displacement, from one moment a person is moving towards the other area in a specific direction. So displacement is a vector quantity and it's not a scalar quantity. If you talk about velocity, you are able to see it here. Velocity is nothing but speed in a given direction. So in a given direction the object is moving. So speed, it's once again a vector quantity, whereas speed, how much fast you can go. So the answer is option D. So speed is a quantity which requires only magnitude. Let's move on to the next question. So dimension of torque. If you talk about dimension of torque, the movement of an object is termed as torque. So if we talk about the dimension, torque is equal to force into perpendicular distance. The unit or dimension for force is m L t power minus 2 into L. So into L in the sense it becomes L square. So dimension of torque is m L and L square into t power minus 2. So over here the option is B. So this is an option. Okay. So this is the next question we are going to discuss about the errors. So over here, if the error in the measurement of the momentum of particle is 100%, then the error in the measurement of kinetic energy. So considering in the momentum I got an error of 100%, what is the change happening? Okay, in the kinetic energy. Before that, we should understand what is the energy. Energy is nothing but the accumulation of a specific thing or property in an object is referred to as energy. So we got a lot of different energies available. One is potential energy. Considering a person is holding a ball, an object got an energy at its position. So this is a pin. This object got an energy. This energy is called potential energy and it's coming down. It's kinetic energy. The object is moving. While motion, an energy is created. They termed it as kinetic energy. You are able to see it here. This one, it got a potential energy. Once if it start moving to hit the nail, it got an kinetic energy. Once if there is a hit happening on the nail, there is a mechanical energy happening. So this is how energy is, and let's move on to the explanation for this problem. Kinetic energy is nothing but half mv square. We got half mv square. So mv square. So here we got momentum. So I need to convert, or we have to include the momentum in this one. So what is momentum? mv is equal to p. This is your momentum. Now what I'm trying to do is like I'll multiply m in the numerator and also in denominator. So m square v square divided by 2m. Over here p is equal to mv. So we got p square divided by 2m. Now you got this one. Kinetic energy is equal to p square divided by 2m. While taking the differentiation, because there is an error. There is an error happening. There is a change happening. So I have to take the differentiation. So differentiation of kinetic energy is differentiation of momentum. So since we got p square, on differentiation you got 2 into d of p divided by p over here. We got this one. So if there is a momentum change of 100%, the kinetic energy will be 2 into 100%. So the answer is 200%. Over here we got an option as D. So here is the option D. Now let's move on to the next question. I think this one is real simple for you. The question is, how many significant figures are in 3400? So if you talk about 3400 significant figures, it's non-zeros from 1 to 9. What is the number available? You should not include 0. This one you should not include, and this one should not include, and 1 and 2. The answer is 2. So we got 2 significant figures. That's the answer. Okay, so Weber per meter square is equal to what? This is the question. So we got an option like a Dine, Tesla, Watt, and Henry. So Weber per meter square is nothing but the flux density, how much the magnetic effects happening on a magnet. So that's nothing but Weber per meter square. So obviously, like how much it's navigating, the magnetic flux is moving towards how much distance. That's Weber per meter square. So the magnetic flux density is calculated in the unit of Tesla. The answer is option B.